grade 9s. Thank you for your some of your comments on Teams getting to me. I see that Miguel picked up my one error because you can factorize further in the common brackets. But I got back at him and I said, no, I actually did that example in the video, so safeguarded myself there. But well picked up, Miguel. And for everyone else asking me questions, thank you. I'm going to try and put together a revision video for Friday. Okay, so we're going to start lesson 3. So we started with factorization at the beginning of this term. So we've done highest common factor, pulling out just the highest factor out of the binomial, so the highest factor out of it. Then we did common brackets, so we pulled out a whole bracket, okay, and then whatever left was in a bracket. And then when the bracket wasn't right, there's a special rule that you must do or apply. Now, some of you are probably already giving me the answer. In class, I'll be waiting for you kids, seeing hands. Hope Zulu's watching because Zulu always gives me his hands. When you pull out when your brackets are when something's not right in factorization, you introduce a negative. So you change the sign and it changes the whole whatever's inside the bracket. It changes, all the signs change. Remember, we hate the negative. Yeah? Okay. So we're going to start with the third piece in, you'll see some of you will ask me, so you've missed a section, so you're going to be writing to me and say, so why did you miss the one? I feel that one's a little bit more harder. You have to create brackets. So I'll do that next. Alright, so we've done highest common factor, we've done common brackets, now we're going to do difference of two squares. So let's have a look at our examples. Okay, so I need to just look at the notes quickly. Let's look at the notes. In the notes I've put here, it says has to be two squares. So what are squares? Squares are, a square can be 1. 1 is a perfect square because 1 times 1. 4 is a perfect square, 2 times 2. 9 is a perfect square, 3 times 3. And I'm sure you're getting the drift. Alright, next one is 16. 16 is a perfect square, why? 4 times 4. So what will be the next perfect square? 25. 5 times 5. And so it carries on. Don't forget 1 is a perfect square. You all get mixed. You all miss this one, most of you. 1 is a perfect square. And then this one over here, it'll only make sense to you once I've started working out. The powers in the question will always be halved. Alright, so let's have a look at the question. So I've got 4x squared minus 9. So I have to factorize this. So when I'm doing difference of two squares, you're always going to come out with two brackets. And the brackets are going to be plus and minus. Always. Plus and minus. And then you look here. What is the square root of 4? It's 2x. I halve this. So what's half of 2 is 1. And what's the square root? What's the root of 3? The root of 9. It's 3. And whatever bracket I have over here, okay, wait, I want to explain something else. Whatever you have here is exactly the same here, but it's just minus. So I'll repeat that again. So whenever you've got difference of two squares, you know you're going to have two brackets. Then you square root this, and you know how to square root this. What's this? The root of 4. What times what will give me 4? 2. And then the power on the actual variable, I just halve it. Or I divide by 2. So it becomes one of them here and one of them. Because when I times this out, what's x times x? It's x squared. And what's 3 times 3? It's 9. So you can even go that way if you want to check yourself. So if you want to check yourself once you got your answer, you say 2x times 2x, 4x squared. And what's 3 times 3? 9. Well, let's try another one. So again, it's the same, exactly the same step. So I've got, do I have a square here? Yes. Do I have a square here? Yes. Is there a difference? Yes. So it's a difference of two squares. Because when I'm doing factorization, so I just want to talk again to everyone. So when you're doing factorization, you always, when you get your question, factorize something, you're asking yourself, am I pulling a highest common factor out? Have I got brackets? Or have I got difference of two squares? So those are 3 that you know. There's another one where it's a trinomial, and then creating brackets. Those 2 are the little bit more difficult ones. Okay. So we look at this question now. Do I have a highest common factor? Because you all think it's a highest common factor. Can I pull a factor out of 25 and 16? And if you think about it, no, you can't. There's no number that can go in 25 into 16. And if you're thinking about it, it's because you don't know your times tables. And then you ask yourself, can I pull an A out of both of them? Can I pull a b out of it? So highest common factor doesn't work. Is there brackets over here? No. So therefore you know now. Okay, do I have a square here and a square here? Yes. And is there a difference? Yes. So it's difference of two squares. So let's start again. Difference of two squares, what do? I know I'm going to have two brackets. And then what times what will give me 25? 5. And I just halve this a. So I have a 5a here. 16 is 4b and 4b. Sorry, I'm a little bit, it's too close. And then you can put plus. Can you look at this question above here? See, I put a plus and then a minus. I can put minus first if you want, and then plus. It doesn't make a difference. Some of you would have asked me in class, so what if I say plus first? Doesn't make a difference. All right, let's look at this one. Now you all look. You're like, sir, this is not difference of two squares. Yes, it is, because there's a silent 1 in front of it. Yeah. What's 1 times 1? 1. And what's 1 times 1? 1. So is 1 a perfect square? Yes. And is there a difference? Yes. So now how are we going to do this? So now you all freak out. What's the first thing we do? Two brackets. Halve that. And then minus 1 plus 1. Let's check ourselves. Y squared times y squared. Y to the power of 4. And what's 1 times 1? 1. Alright, so you'll see the exercise I've given you is a whole bunch of, the first one, I think I gave you 16 to do. You're going to all freak out. Oh, so many. But it's all easy ones. All basic squares. There's nothing hard. But it's to repeat and to repeat and to repeat. So you practice, practice, practice. You'll see you won't put the two brackets. You'll just know. You won't have to put, what I mean by you won't have to put the two brackets. You know when I started, I put a bracket. And then I put a bracket. You won't even have to do that. That's just to get you to understand. When it's different on two squares, there's two brackets. You'll see once you get into this, you won't have to put the brackets. I'll show you now. I won't put the brackets. I'll just work it out. But they get difficult. So yeah, you're gonna see now the next question is a combination question. It's got highest common factor and difference of two squares in it. So let's have a look. Look at this question. So now, some of you will know now, you'll say, hey, sir, this is highest common factor. You're correct. So what do I pull out? I pull out a 2. So if I pull a 2 out, I'm left with m squared minus what's half of 72? It's 36. That's when I need you kids with all your good math, your good multiplications. All right, now look at this. Now do I have a difference of two squares in there? So some of you will do that and you'll get 1 mark on the test, but there's an extra step now. This is a difference of two squares. Is there a 1 in front here? Yes. Is that a square? Is that a square? Yeah, 6 times 6 and it's difference. So there I have to do it further. So now I'll have m minus 6, m plus 6. Difference of two squares. Alright. And then here is the hardest of them all. So this one over here, most of you will get wrong. I'd say about 90% of you will get this wrong in the test. And there will be a couple of these in the test, but it won't be worth, it will be worth 10% of the test. Okay, so here, you should recognize that it's a difference of two squares, but it's not a difference of two squares. It's an n squared and there's a 16, so there's a square, because you must factorize this. How do you factorize this? So you should be thinking now, what am I going to do? Then I taught you a concept about introducing a negative. All right, so if I introduce a negative, what's going to happen to this whole expression now? It changes signs. You know, the previous examples that I showed you, the previous work I did with you guys, when we did factorizing by pulling out a common bracket, the section B of that question was where the brackets weren't the same, they were different. And you had to introduce a negative into it and change the signs to make the brackets the same. Here again, you have to do the same thing. So let's have a look. So I have introduced a negative, and then this will become, it was negative n squared. What will it change to now? It will change to n squared. And this was plus 16. Now what will it change to? Minus 16. And now what is that? That is a difference of two squares. So my final answer will be negative, open bracket, n minus 4, n plus 4. Difference of two squares. So n times n gives me n squared. 4 times 4 gives me 16. Negative and a positive times a positive and negative. Okay, so that was a hard one. So this one is the star. The kids in class know I put a star next to them and they know, they just leave it out. All my lazy kids, you know who you are. The ones that I put stars on, you just leave out. You'd let me do it the next day and tell me, sir, I just couldn't. So guys, it's a pity I'm not with you in class. This is why I'm doing this for you kids, because this is it gets tough. Okay, so you're starting to, but difference of two squares is easy once you grasp the concept. Okay, so I'm thinking about just doing one off the cuff here, but it'll be hard because let's just check here. N squared minus 4. Okay, let's just quickly recap. This is a simple one. So I've got a difference of two squares. So what do? You're going to have to come from the side so you can see I'm working this out. Okay, difference of two squares. Alright, so I'll have x minus 2, x plus 2. Those are the simple ones. Let me do another simple one. 16a squared minus 1. It's a difference of two squares. So I'll have brackets 4a minus 1, 4a plus 1. So whatever the bracket is, it's the same, but just the signs change. It's difference of two squares. And then this one is a very difficult one. You can just replay the video. And then this one is a routine one that you should know. You pull out a highest common factor first, and then you do difference of two squares. So I've put the work up for you guys. I hope you enjoyed the video. For those of you that are not from my class and are watching the video, I hope you like it. And yeah, let's see how far we get. Thanks guys. Cheers.